So for 3B, the road is level, but the car is accelerating, and it's got to pass another car. So in the acceleration, it's going to delta x, delta t, v naught. We get all this information, right? We know that it takes 6 seconds to pass this car, and it's going from 90 to 110. 90 kilometers per hour to 110 kilometers per hour. Again, we have to convert those to meters per second. So let's do that. So we have this is equal to actually 25 meters per second, and 110 is equal to 30.55, 30.56 maybe meters per second. It's five repeating. So we have our three unknowns. I don't know, don't care about this one. And I want to know what the acceleration is. So the acceleration, we will use the one without delta x. So it's going to be v equals v naught plus a delta t. To find a, it's just v minus v naught over delta t. So that's going to be 30.56 minus 25 over, the time is 6 seconds. So my A is going to equal 30.55555 minus 25 equals divided by 6. So 0.9 is the acceleration, 0.9259, 0.9259 meters per second squared. Now I want the acceleration because what I'm after, it ultimately is the, let me find a pen here. What I want to do is put in the force. We want to know what applied force, FA, is required. FA, not FG. FA is required. And we're still overcoming the same 700 Newton force of friction. That hasn't changed, right? So the force is going to be that. Now, let's see. In this case, what we're going to do now is look at our forces. So FMA equals the sum of the forces. So we know what MA is, but we can put sum of the force is going to be FA minus FF. So in this case, FA is going to equal MA plus FF. So it's going to equal 1400 times 0.939259 plus 700. So calculating all that, my applied force, 0.9, so when you do that math, it's 1,996 newtons. That's what the applied force. In order to maintain an acceleration of 0.925 with a force of friction of 700 newtons. So the power is equal to the force times the speed. Now, what speed do we use here? Well, I mean, if you're going to end up going 30.56, you're going to have to be able to maintain that power, right? So we're going to use the top speed, 30.56, for this, because if we didn't, then it wouldn't have enough power ultimately when it's going faster to keep accelerating at that rate. So that's what speed we're going to use. So just keep that in mind. And now our power is just going to equal 1996 times 30.56. And that equals 61,000 watts. So the power is 61,005, 61,005.7 watts. Again, if you wanted to be better with the significant figures, you'd say 6.1 times 10 to the 4 watts. And that would be the answer to part B.